Okie dokie. Excuse me. So, week 28, part 3. Here goes some expert advice on Khan Academy questions. So, we're using this stuff. And then there's another page with the half and double angle identity. So, you should totally have those out in front of you. And we're going to go through question 1, 2, and 3, 4. So, please, would you draw this, okay, for question number 1. And what the question asks is find the sine of, I'll zoom in here. So here is the triangle, and it says find the sine of angle ABC plus 60 degrees. So angle ABC is right here. And I think for the sake of ease, I call that theta instead of ABC, just because it's easier to write. But notice how we have the sign of something plus something. So we're definitely going to be using the addition identity for sine. And, well, that's the question. All right, so you have that written down. Let's take a look at the solution. You, of course, could try to solve this by yourself. So first thing is look at the triangle here. Okay, we have a 3, 4, 5. So we don't know exactly how many degrees that is. Tempting to say this is a 30, 60, 90, but it's not. All right. Oh, gosh. Oops. I forget which answer choice this was pointing to. Okay, I think it's right there. Sketchy. Okay. So the first thing you want to do is if this is the angle, right, this is the adjacent, this is the opposite, this is the hypotenuse, so we can say that the cosine of the angle is adjacent over hypotenuse, so 3/5. And we can say the sine of the angle is 4/5. We don't know what the angle is. We don't care how many degrees or radians it is, but we do need the cosine and the sine of that angle. So the question asks us for sine of the angle plus 60 degrees. Sine of the angle plus 60 degrees, so here's our addition identity. All right, sine of the angle cos 60 plus cos of the angle times sine of 60. So sine of theta we know is 4/5. Cosine of 60, we use our unit circle skills, we know that's 1/2. Cosine of the angle is 3/5. And sine of 60 degrees, we use our unit circle skills and get this, √3/2. Multiply 4/10, multiply 3√3/10, and then 4/10 simplifies to 2/5, and voila! Cool. I mean, wahoo! So, some points there. Let's see. Same thing. So here's question number 2, but here we have the subtraction identity. So if you want to give this a whirl, meaning try it out by yourself, that'd be cool. We have a triangle, and we're asked for the sine of angle ABC minus 60 degrees. So you could try that, or just watch. So here's our angle ABC. We know this is the adjacent, this is the opposite, this is the hypotenuse. So the sine of the angle, opposite over hypotenuse, 6/10 reduces to 2/3. And we know the cosine of the angle adjacent over hypotenuse is 8/10, which reduces to 4/5. Okay. So sine of the angle minus 60. And again, this is angle ABC, but I'm not writing all that in. So looking at our subtraction identity, looks like sine of the angle times cos 60 minus cos of the angle times sine of 60. So here's where we got these values. Sine of the angle is 3/5. Okay. Cosine of 60 from our unit circle skills minus cosine of the angle, which is 4/5. Times sine of 60, which we get from our unit circle skills. Multiply, multiply, 3/10. Multiply, multiply, 4√3/10, and we're subtracting. I think this reduces to 2/5, and let's see. Aha! I see an answer that looks like our... Wow! We got it right. Okay, good work. So here's question number 3. If you would draw this triangle, this is different now. I think this is from the other skill that we'll be doing. And it says find sine of 2 times angle ABC. So it's really similar, We have ABC, and so we're thinking about this angle. But here we're using the double angle identity. So sine of 2x, and so you have a page with the double and the half angle identities on it. Sine of 2x is 2 sine x cosine x. So well, you could try to solve. This is a free response, or I'll show you next slide. So if this is our angle, again we have adjacent over hypotenuse for cosine of the angle, and we have opposite over hypotenuse for the sine of the angle. And our identity, our formula, says that sine of 2 theta is equal to 2 sine theta cos theta. So we know it's 2 times 4/5 for sine of theta times 3/5 for cosine of theta. Alright, and then we're multiplying. I think some students might mess this up. This is 2 over 1, right? 2 goes to the numerator, 1 goes to the denominator, so these are numbers we multiply. We get 24/25. So I went through some of these. I typed it in as a fraction, and voila! Cool! Alright, so I typed in 24 over 25, and they told me the answer was correct. Ooh, awesome. Show some points. Yeah, let's see that. Alright, number 4. So, alright, find trig values using angle addition identities. So this is the same, this is the first set of identities that I showed you in this lesson, but question number 4 is this, essentially. Woo! So, right there, find the cosine of 165 degrees, that's the question. And we're looking for an exact value, so we're looking for two angles that add or subtract to 165 degrees. So you could try this if you'd like, or hang tight and we will solve it on the next slide. Alright, so 165 is 135 plus 30. Why did I choose these? Well, I chose those because we can do this. Cosine of 135, we know that from the unit circle, and cosine of 30, we know that from the unit circle. The whole point of this is to be able to break this down into angles that we know the cosine of. So, our addition identity for cosine says cosine of this plus this will be cos 135 cos 30 minus sine 135 sine 30. And this is all unit circle, all this stuff. Cosine 135, that's right there, right? So cosine, we have a negative root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 135 is root 2 over 2. And sine of 30 is 1/2. Look at all this wonderful unit circle practice we're getting. Love it. So multiply, multiply. We got root 6 over 4 with a negative minus root 2 over 4. And we can combine them like that. And lo and behold, somewhere around here, we have an answer that looks suspiciously like ours. And voila! Oh yeah! We got that. Okay. So, good work, and thanks for listening, and this is Khan Academy. Correct. Show some points. Good work.